Hello everyone. Uh, as a part of peer graded assignment under managing machine learning projects, the assignment which is under module 2, under it I have been given this task of finding a problem which is a genuine problem and which can be taken care by machine learning model, and how we can do that problem with the help of machine learning model, and what will be the various phases and processes which will be involved under this. So the first question which I'm going to answer is opportunity evaluation. Under that, the introduction to the problem is to help law enforcing agencies finding the antisocial elements from constant video footage of CCTVs installed in public places and alert them in the real-time basis. So the problem was, normally if any antisocial element which is on the run and law enforcing agencies or on search for that person, it is really a long task. So they need to be on track of wherever they can, on the footsteps to find where that guy or that antisocial element can be, or are the public places safe from those antisocial elements. So this machine learning model, uh, which will take the input from all the CCTV footages, um, taken from the CCTV cameras which are installed in the public places, and this machine learning model will take these streaming of this data, and then model will run and try to evaluate whether the person is the person of interest. I mean, is the person which the law enforcing agencies are searching for, and if it is a person, if it matches with that data, then this model will give an alert or flag to the concerned uh, law enforcement agencies, so that they can be, they can quickly turn up and take whatever actions are to be taken. So this was the problem. So the first question was, is there a problem? For me, yes, it was a problem. And normally how it was done till now, as I told you that, if any person is on run and law enforcement agencies are trying to keep track, so they will try all the traditional modes. It could be a beat constable, it could be, uh, a beat car which is going around, or it could be taking help of law-abiding citizens, maybe uh, media, whatever the traditional mode are to find that person. So there was a problem. Definitely there was a problem. Can ML help solve it? Yes. If we are able to train our ML model and install it on those CCTV cameras, yes, definitely we'll get a help from that. Does someone care? Yes, definitely. If this model is up and running, it will be a great help to the law enforcement agencies. They can take help of this model. So these were the answers to the first question. Then the second question was, uh, as per the CRISP DM business understanding, what could be the success outcome? So for me, the success outcome could be a reduction in the time and resources to identify, flag the criminal. Because normally in the traditional mode, the time used to be quite huge, and plus there was no guarantee that if a person is roaming around in the streets, he might be caught by the law enforcement agencies. But if we have this model in place, we have considerable improvement in the time in which that person can be taken care of by the law enforcement agencies, plus the resources uh, employed to get that person will be very much reduced. So we have in terms of cost, it's a great reduction as a success outcome. As a success output, uh, if we will be having a lower mean square error of the aggregate predictions, that means our predictions will be much more to the more, there'll be a more on the correct side. Factors identified, what will be the factors? It will be how the CCTV cameras are placed on the public places, time of the day, that means is it is the evening, is it a night, or it's a noon, because the light will be a factor in identifying those persons that roaming on those streets. So time of the day is definitely a factor. Density of the people walking on the street, definitely, because the more people are there, uh, the this could be a factor. If there are lesser people, I mean, if there is a huge crowd, finding the persons could be a factor which could be affected in this. Then location and concentration of the assets. That means, uh, say for example, if you have multiple cameras which are focusing on the same street, so that means you have high concentration of cameras. So finding that a person of interest could be, our model could be more precise in finding or locating that person. Trees means if you have trees on the road, on the right side, on the left side, which might hamper the vision of the cameras. Seasonality means, as in, whether it's a snowy, it's a winter, it's a summer. So seasons of the year can also impact. So this is also a factor. Next question, which was a solution validation. So for validation, normally, uh, what we do is, because you don't straight away invest uh, in any model, because you have to do R&D before you invest in a model, as it's a huge investment. So we do R&D. That means uh, we do a sort of hypothesis. We create a hypothesis, we test that, and then we run it. And if it is, then we get the feedback. And after that feedback, if it is on the right track, we further improve it. Or if it is not on the right track, then we again tweak that model. So that means we keep on constantly doing that. So it's not a linear process. It's a basically iterative process. So that means we keep on iterating the itself. So uh, say for example, we will start with the model with the mock-up of the potential solution. We came up with the solution. Then as per the CRISP DM, that will be a business understanding. Then we'll take a small subset of historical data which has been used, which has been captured by the law enforcement agencies, and we will use that, and that will be business understanding, data understanding, and mocked up model. So that will be just a small subset of that data will be used. Then we'll be using real data with heuristic as model. Heuristic means we'll be using a simple model, not ML model. Uh, Heuristic also means that which is an obvious model, which we will not be employing the ML model into it. And with the real data, we'll be using heuristic as a model. So that will also comes under business understanding, data understanding, and data processing. Then we will now use real data with simple ML model. So basically, real data with heuristic as a model, that will create a first baseline for us, because baseline is very important. Until unless we don't have baseline, we cannot see whether we are improving in our performance or we are at the same level. So once we have created this first baseline, now we will use the real data and we'll use a simple machine learning model, and that will come under business understanding, data processing, modeling. So and then this will go on and on. So now we have created a simple model, then we go on, as I told you, that we'll be now improving on that thing. And if we are then or on the right track, that means our hypothesis is working, we'll be improving that model. If it is not, then we'll again change that model, tweak that model. So this is an iterative process which comes under CRISP DM steps. Now, once we are going, iterations are going on. After that, when we reach some stage, we now check the performance on the test set. So initially we use the training set, then we'll be using the test set. And then also we use customer testing. That means customers will be testing with the live data, because we use the test data, we use the training data. Now we'll be using the customer testing data. And then we'll be debugging with the data issues. So this was how we'll go about the validation. Now the next question was machine learning system design. What will be the system design which we'll be using, right? So we had an option of because before I attempt this answer, we have to be clear in this thing. Our environment, our constraints in the model, they help us. I mean, they are the driving factors for choosing the design of the machine learning model. And once we have chosen the design of the machine learning model, then we'll choose the technology which is to be used. So these come, one after another. So first we will see what will be our constraints or what will be our environment in which we'll be using it. So I had the option of cloud versus edge, offline learning versus online learning, and batch prediction versus online prediction. So amongst the cloud and edge, I chose edge. Amongst the offline learning versus online learning, I chose online learning. And amongst the batch prediction versus online prediction, I chose online prediction. I'll explain in the next slide why I chose edge, online learning, and online prediction. So why I chose edge? Because uh, our CCTV cameras, they, there is every chance that uh, they will be computing in the real time. So that means computation done directly on the device. So we cannot be dependent on the cloud, because some CCTV footage, if it is a cloud based, that means definitely you need to have some network connection. So we never wanted that our CCTV cameras are dependent on internet. So we will go for edge, because edge does not need connectivity. So computation is directly done on devices. Sufficient computing power is there, and memory is also there in the current edge devices. Low latency means, because if it has a high latency, then it will require processing time. So we don't have that much time. If it is in the cloud, it will require processing time. So that's why we require, in edge devices there is low latency, and it is apt for our requirement. And sometimes we can use hybrid approach as well. In a hybrid approach, uh, we have some amount of local computation, but then based on some trigger, the data can go to the cloud. So this mechanism can also be used, but mostly I will go for edge. Then online learning. Why did I choose online learning? Because there is a continual retraining as new data arrives, minutes per hours, so minutes or hours. So that means we are getting data constantly. That means the crowd is moving 24/7. I mean, you don't find people coming again on the same street. So data is continuously coming using each new data point. So we have new data points coming up. So that's why our system will be doing online learning, and our system will be handling big data, because the crowd is coming, and every time there are new faces coming up in the street. Real-time adaptation to the changing environment. So that's why, because of these things, we will be going for online learning, because our it is a real-time adaptation to the changing environment. Now, why I went for online prediction? Because real-time predictions generate upon request, predictions available immediately. So if the opposite of online is offline, which it does the predictions after some intervals, which could be a weekly, which could be, fortnightly. So we cannot wait for that much prediction time, because anytime if any anti-social element is on the street, we cannot wait for 1 week to predict that yes, that guy was, which was, uh, law enforcement agencies were lookout for him. So it has to be immediately. So and also it minimizes the latency and monitoring of the model shift. So that's why I chose edge, online learning, and online prediction. Now, that for this question, what were the potential risks which I could see in my model? So first was training serving skew. So that means data could change what was there in the training and what was there in the live environment. So that means, say for example, the profiles or getup of the people might have changed. That is, the appearance of a suspect in a test might be different from his or her current appearance. So whatever the data was in the test, right now, the profile or maybe getup of the that person has changed. So that means the data at that time when the system was trained and now it has changed. So that means there are chances, and also there is a other option also, that also identical looking profiles might show a skewed result. So there could be chance that two faces which are similar. So there also the training and serving skew can happen. Second is latency. Latency means although we are using edge devices, but even so edge devices mean low latency, but there can be somewhere chance if volume of input data is too high or data pipeline is too much heavy, or choice of model which you have used. So that could be factors which could increase the latency. Then the data drift. Data drift means the data can change. Uh, so if the model is trained on the data captured during summer, so for example, the data of the profiles in which our model was trained, it was for the people who, wearing summer clothes or during the summer season. Then during the winter or snow period, when people tend to cover faces or wear caps, the performance of the model will decrease, because obviously in winters people tend to cover their faces or wear caps. So uh, maybe the same person, uh, might be having a different get up, which will impact the data. So that comes under the data drift. Then under concept drift, we might say that uh, during extreme hot weathers, people would not like to walk on the streets. So because obviously if you have temperature going soaring high, people will not roam in the streets. So there is a shift in the relationship between inputs and outputs. Why? Because our model was trained on the, when the people were roaming around, maybe when the environment was quite pleasant for the people to roam around. But now it's quite hot weather, so there's a concept drift, which means there's a shift in the relationship between inputs and the outputs. So these were my findings on this project, and that's all. Looking forward to the feedback from peers. Thank you. You have a great day.